All right, welcome to this episode where we're going to talk about SD-WAN, and I'm again going to attempt to address what it is. And I want to talk about what it is in the context of how I would deploy it and how I would interconnect it and exactly what it is that I'm going to be doing. And again, it's going to be described inside of the context of the NFP again. Again, I'm going to be talking about my three planes of operation. So what we're going to do is we're going to look at it from the perspective of the management plane, we're going to look at it from perspective of the control plane, and we're going to look at it again from the data plane. Now, specifically, when we drew the corollary to the 6500, we said that the data plane forwarding was handled by line cards. Now, what I would really like to do is I would like us to be able to imagine the fact that I can actually have multiple locations. So let's just say, again, like I said earlier, let's say I have Texas and let's say I have Virginia. Again, just drawing the corollary to what I was describing earlier. And let's imagine that I wanted to put a forwarding construct, a device that gives me the capability of being able to forward data. We're going to start from the data plane and we're going to work our way up. So that device would be the equivalent of, say for instance, a line card. So if I was to break my 6500 up and just deploy the line cards across a large area, ultimately I would end up with something like this. I'd have my line card 1, let's say I'd have line card 2, Texas and Virginia. Now, ideally, what I want to be able to do is I want to be able to take these line cards and I want them to have all the functionality that they would have if they were inside of the same chassis, but obviously I can't stick them into the same chassis because they're in completely separate locations. So instead of having a chassis fabric, what we're going to do is we're actually going to choose to use some other solution as a transport fabric. And that transport fabric is going to give me the capability of being able to have these devices send information from one line card to another. So actually what could happen is data could come into this line card and data could leave this line card. Now we'll get into this mechanism when we start talking about what it does for me, because right now I'm still trying to address what it is with regard to it being a distributed switch that is again going to be, as I said, cloud distributed. Some people like the term cloud scalable, which I'll go ahead and put that in because that'll be in most of what books you're going to read. Now, we need to make certain that we have the functionality to allow these resources to work together. Now, the data plane is just part of it. In fact, as we have learned, if we know anything about networking, we know that we can't have a data plane unless we have successfully configured the control plane operation. So as an example, spanning tree needs to have a root bridge. A OSPF neighbor adjacency on a broadcast network is going to have a designated router. So there are going to be constructs that we're going to need, things that we're going to have to elect, things that we're going to either have to assign, and what we're going to do is we're going to have to address that inside of this cloud scalable fabric that I'm basically using to replace the switch fabric. Now, the way that we're going to actually implement this is that, again, what we're talking about right here is, like I said, the data plane. And in Viptela, what will end up happening is we don't use line cards. Obviously, we're going to use switches. We're going to use routers. And they are going to come to us in various forms. We have virtual switches like V-Edge clouds. We have ISR 4000 switches in XE SD-WAN mode. We have a number of V-Edge devices that were manufactured by Viptela and embraced by Cisco during or at the acquisition. So what we're going to do is we're just going to come over here and we're going to call these things V-Edges. And I'm going to have multiple V edges in this deployment. Now, this is not meant to say that I can only have two. I can have as many as I need in my infrastructure, but ultimately, like I said, these resources need to be able to communicate with each other, and I can't do that. I can't send data from here to here without first having some type of control plane construct that's going to allow me to be able to orchestrate that entire mechanism. So what we're going to find is we're actually going to typically be deploying constructs that are going to allow us to be able to emulate the behavior as if these were in one physical chassis. Again, it's a distributed switch. I'm distributing components of functionality across a geographically disparate area. And I'm doing it through the creation of a cloud scalable fabric. And that's going to use IP for transport. Now, I can have multiple solutions in here. Right now, what I'm focusing on is purely using the internet to set up the functionality, because the control plane functionality is actually going to be embedded in the internet. Now, at first blush, students are like, well, isn't the internet a little lossy for this to actually take place? I mean, it's not like the backplane of a chassis, because the backplane of a chassis was purpose-built from day one to have all the necessary resources to allow all of the complement line cards and controllers to work. Well, the answer to that question is yes. It is lossy. However, what we're going to find is that we've adopted mechanisms inside of the software-defined infrastructure that's going to allow me to be able to readily recover from this information or from anything that might be considered as lost or dropped in the internet infrastructure. And we do that by making things very, very stateful. That's the perfect word. A stateful mechanism. And whenever we have stateful operations, whether we're talking about Cisco or we're talking about VMware or we're talking about any manufacturer, we have role-based behaviors. And just like the V-edges, the VEs, were the devices that handle the forwarding of data, inside of Viptela, we have something called the V-smarts. Now, these V-smarts are just virtual machines. They're VMs. And I can run them in Red Hat Enterprise Linux. I can run them in the VMware vSphere. I can run them in AWS, Microsoft Azure. And the key element here is that they are simply just virtual machines. And I can cluster them if I need to be able to have or want to have resiliency and high availability and all of those components. But right now, we're looking at everything in its purest form. And the control plane construct is going to end up being one or more vSmarts. Now, the vSmarts are going to be responsible for creating all of the control plane information. And then that control plane information will ultimately get passed down to the data plane for the purposes of forwarding. So if I were to draw a network infrastructure here, I would have my vSmart connected to it. And again, I could have one or more vSmarts. Now, the other part of this is okay, now I've got a mechanism that's going to allow each of these devices to be able to communicate with one another in such a fashion that I can compile control plane infrastructure. So I can build tables. That's the biggest thing here. And I can also implement policy. Anybody that does anything in networking now would have to be living under a rock if they've never heard of things like intent-based networking or policy-based networking. And that's what SDN is. By its very nature, SDWAN, excuse me, by its very nature, SDWAN is going to allow me to implement policy to enforce behavior and functionality and scalability. Also, it's going to give me an entire new playbook that's going to allow me to be able to selectively pick paths that I may want to choose to use to send information, say for instance, from one V-edge to another V-edge, with the concept of application awareness. That's going to be another component here that's very, very important. What is SD-WAN? Not only is it a cloud scalable fabric, it is an actual application aware cloud scalable fabric that is going to allow me to be able to send data in a controlled fashion between resources by treating them like they're part of a distributed infrastructure. Now, the next component that I'm going to need to be able to manage things is going to end up ultimately being my management plane construct. So in the management plane, I now have another virtual device. We call that virtual device a vManage. The vManage, again, is a virtual machine. So it's just a VM. And again, I can have high availability. I can actually do a number of things with it. But just keep in mind that that is going to sit also out here. My, let's say VM for vManage. Should have done a better job at the sub component of this. So that's going to be where I'm going to access to do my implementation. This replaces my configuration with regard to how I'm managing devices, and I'm going to create policy, I'm going to implement policy, and I'm going to do my configuration on the vManage resource, or the vManage device. Now there's one other piece to the puzzle that's missing here. And if you think back to the way normal networking functions, if I had all of this crammed into a chassis, everything would have dedicated backplane connectivity to allow all of my internal operations. Now, when it comes to SD-WAN, we still have the exact same functionality, but we got a different means of being able to do it. Because what will end up happening is we're going to find that each of these individual resources that I'm describing are going to be defined by their own IP address. So as an example, my vEdges, from the perspective of management and control, are going to have IP addresses that I'm going to use to communicate with. However, my problem is discovery. So how do I learn about these vEdges, and how do I propagate information to these vEdges? And the way that I do that is going to be through the implementation of another plane, and that's that fourth plane that I was describing. I want you to visualize something called the orchestration plane. So outside of NFP, but inside of SD-WAN, I have management, control, and data plane constructs, and I also have something that I'm going to refer to as an orchestration construct. That orchestration construct is going to be responsible for a number of things. It's going to be responsible for setting up the configuration. It's going to be responsible for enforcing and deploying configuration settings. But right now, for the purposes of our conversations, its biggest job is going to be network discovery. So I've got all of these components scattered across an IP distributed infrastructure. And I need to make certain that I have the ability of, first of all, identifying every device that's going to be part of this distributed switch. And I also want to make certain that the communications, especially from the perspective of control plane configuration, is going to be secure. So I'm going to implement that using another virtual machine. And that virtual machine is called the vBond, sometimes called the orchestrator. And that's why I make reference to it as being part of the orchestration plane of operation. The vBond, again, sits out here and is also going to be connected to some mechanism that's going to allow these devices to all communicate with it. So when we take a look at the actual operations and we build our SD-WAN architecture inside of the emulation environment, we will be using vEdge cloud routers. We will be using vSmart, vManage, and vBond, and we're going to learn about all of the operations, all of the configurations that are going to go into successfully creating this config. Now, the reason that I did the vBond in red is the vBond must be reachable by all of these devices. It needs to be accessible on the internet. Now, Cisco will host all of these for you if you want them to. Obviously, that's a service that you can pay for, and we get what we call ZTP, Zero Touch Provisioning, which we're going to be talking about in later videos. But right now, what I'm doing is I'm going to be implementing in our lab what I call an on-prem solution. Now, with an on-prem solution, we're going to be responsible for building everything from scratch, which means we're going to be implementing all of the components that are going to allow us to be able to obtain secure communication. We are going to use protocols like DTLS, TLS, as well as certificates to be able to build this distributed infrastructure. So I want to give this some time to sink in, and I really think that I've done a relatively good job answering what is the software-defined WAN solution that Viptela provided and Cisco acquired. And like I said, it really boils down to, in its purest and best deployed form, it is a zero-touch provisioned, application-aware, cloud-scalable fabric that's going to allow me to be able to obtain wide area network connectivity across a disparate geographic area between resources called V-edges. Now that doesn't necessarily answer 100% of what it does for me. And what we're going to do is we're going to address that in another video. It won't be the next one, because in the next video what I actually want to do is I want to assemble this solution and walk through each component architecturally step by step, and we're going to begin with the vManage. I'm Terry Vinson, and I'll see you guys in that video. Until then, have fun studying.